Hi, in this video we're going to learn about how capacitors discharge and charge in a circuit. So in this circuit here we have one capacitor and one resistor, and let's say that this capacitor has a voltage V0 and this capacitor will discharge because this is a voltage source and it will discharge across the resistor. The equation that describes that discharge is V of t is equal to V naught e to the negative t RC. So we could see in this equation, it first starts off with V naught, and then it will exponentially decay due to e to the negative t over RC. And this is what the graph will look like. We could learn more about this equation by trying a few points for t. For example, when t is equal to 0, e to the 0 is 1. So the voltage at t is equal to 0 will just be V naught, which makes sense because there was no time that passed for the capacitor to discharge anything. And then now, if t tends towards infinity, e to the negative t over RC will tend towards 0 because this term will become smaller and smaller since it's a negative exponential. So that means that V infinity will also tend towards 0. And now we could also try a few values for R and C and ask ourselves why bigger or smaller values can affect the time at which V of t changes. So let's imagine if we have a very big resistor here. If there's a very big resistor here, that means that the amount of current that will flow due to a voltage will be less because this is just a voltage source. And this is the reason why a big resistance will cause the exponential decay to last longer. And the same thing for capacitance. Capacitance means the amount of charge there is on the capacitor itself, since the equation for capacitance is Q over V. So if the capacitance increases, that means that there's a lot of charge on this capacitor that can be discharged through the resistor, which is why C is also in the denominator. A bigger C will cause this exponential to decay longer. And luckily, the equations for current and charge through this capacitor is also the same. I naught e to negative t over RC, and then Q naught e to the negative t over RC. For charging the capacitor, the circuit changes by adding a voltage source in series with the capacitor and resistor. Let's say that this voltage source has a voltage Vs and the capacitor has an initial voltage V0. And in this case, we'll assume that V0 is 0 volts. So the graph of the charging will look like this. And the equation that describes this graph is Vt is equal to Vs 1 minus e to the negative t over Rc. So the charging also has an exponential relation. And we can again put times for t to see how the output Vt reacts. So let's say that t is equal to 0. If t is equal to 0, that means that this term is 1. And then 1 minus 1 will be 0. And Vs times 0 will be 0. So V 0 will equal to Vs times 0. And that makes sense because if no time has passed, then the initial voltage of the capacitor will still be at that same voltage, which is in this case 0. And now let's test what happens when t goes to infinity. When t goes to infinity, this will tend towards 0, since this term will get smaller and smaller as t grows larger and larger. And as this goes to 0, that means that it's just Vs times 1. So that means that V infinity is equal to just Vs. And from the graph, we see that that is what is happening. It plateaus towards a voltage Vs. And intuitively, this also makes sense because the capacitor wants to match the voltage of the voltage source. So eventually, it will rise steeply and then it will reach the same voltage as the voltage source. And then after that, these voltages will cancel out and there will be no more current running through to charge the capacitor. I hope this video helps. Thank you.